Question 2c. Calculate the size of the induced voltage across this wire above here, providing the correct unit and the correct number of significant figures. When we read that, this idea here of correct unit and this idea here of correct number of significant figures should hopefully just jump straight out at us. Okay? Correct unit, well, calculate the size of the induced voltage, so we know that the answer is going to be in volts. If we have a look up here, that there's two significant figures, two significant figures, and two significant figures, so our answer must be to two significant figures. By simply writing these two here, we have gained two achieved grades. Now let's have a go at answering this question. Size of induced voltage. Let's have a look at our formula sheet. Well, voltage equals magnetic field strength times velocity times length. And that's what we just saw in question 3b, where the distance that the charges had been separated was related to the amount of potential energy they had, just like the height we lift something off the ground is related to the amount of gravitational potential energy it has. So voltage is linked into this idea of length. If that doesn't make any sense to you, that's fine. Voltage equals BVL, where B is the magnetic field strength, 0.80 Tesla. The velocity is 12 meters per second, and the length, we look up here, is 65 centimeters. Now, centimeters an SI unit? No, it has to be meters, so it's 0.65 meters. We can head over to our calculator. 0.8 times 12 times 0.65, done, 6.24 volts. Now that was a pretty simple question, and so it's only worth an achieved. Question D, the wire is now connected to a resistor. To make a complete circuit as shown in this diagram, the resistance of the resistor and the wire is 4.5 ohms. Okay, so R equals 4.5. Calculate the size of the current through the resistor as the wire is being moved in the magnetic field. So we're just going to use V equals IR, Ohm's law. And we're looking for the current, so we're going to rearrange this equation to make I the subject. I equals voltage divided by resistance. What's the voltage? Well, everything's exactly the same as our previous question. So the voltage is going to be 6.24 volts. Now say you hadn't worked out that voltage correctly, or you had no idea what the voltage was, but you got the idea that you needed to use Ohm's law, then you could have made up the voltage and made it up and written it in C and written it now in D, and you would get the right answer. You'd get a carry error. We can simply type that into the calculator. 6.24 divided by 4.5 equals 1.39 amps. Now, is that the end of the question? No. If you got there, that would be worth an achieved. Let's read the rest of the question. Draw an arrow on the diagram above to show the direction of the current through the resistor. Okay, this is where the right hand rule comes in again. Okay, we have a velocity which is going down the page. We have crosses, which mean that the magnetic field is going into the page. So our fingers go into the page. Our thumb goes down the page. And we get our positive charges here, our negative charges here. This acts essentially like a small power supply, and so the current actually goes this way. Current goes that way. Okay. Also with that front slap also means the direction the current goes. Okay, so this wire moving through this magnetic field is just like a power supply, where this end is the positive side and this end is the minus side, and so conventional current goes through the resistor in a anti-clockwise direction. That is now worth a merit.